UJT, unit junction transistor. Unijunction transistor. This construction is same to that of FET only. The construction of UJT is similar to that of FET. Draw this one. So this is P-type material. P-type emitter. Now this is N-type slab. So for this there are two bases, base 2 and base 1. Base B2 and base B1. So this will form a PN junction. This is the construction of UJT. So an N-type silicon material base is there. Slab for this P-type emitter is added here. So there are two bases, base 2 and base 1. So generally here, see the circuit diagram, circuit symbol of UJT. This is VBB. And it is VEE. The resistance here is RE, emitter resistance. So this is called emitter here, emitter. And this voltage is VE. This is the circuit symbol of UJT. So this P-type emitter. So here PN junction will be formed. The emitter resistance is RE and bases are B1 and B2. So there are internal resistances for B1 and B2 also. They are called RB1 and RB2. We'll try that once again. This voltage is VBB. Yes, have you taken this, ma? Yes, students. Have you drawn this?
Yes, sir.
Remaining students not responding. Boys, are you there?
Yes, sir.
Yes, sir.
No. See the symbol of UJT. This direction, emitter direction indicates the conventional current direction, same as in the transistors. The emitter, base B2, B1. This is symbol of UJT. If you see the equivalent circuit of this UJT with internal resistances, This is a PN junction. So base B2 has internal resistance of RB2. Similarly, base B1 has internal resistance of RB1. This point is indicated with A. This is IE, emitter current. VE. Same, remaining is VBB. So difference between figure B and figure D is only internal resistance I am adding here. B1, B2. This is the diode voltage VD, 0.7 volts. Just like if it is greater than cut-in voltage, then it on. So this is the equivalent circuit of UJT. RB1 and RB2 are internal resistances. Yes, the students have taken this one. Figure D. Yes. Please respond immediately.
Yes, sir.
Yes, sir.
So with respect to figure D, that is equivalent circuit of UJT, I will explain the operation of the UJT. Now when IE is equal to 0, the emitter current IE is equal to 0, then the resistance between the two bases is called then the resistance between two bases is called interbase resistance. Interbase resistance or BB. Interbase resistance or BB. So when I is equal 0, what happens here? When I is equal 0, this is open circuited. There is no connection here. So what is the total resistance here from B1 to B2? That is RBB. That is equal to RB2 plus RB1 or RB1 plus RB2. Are you getting this? When IE is equal to 0, so this there is no connection here for point A. Here there is no connection. When there is no connection, it is isolated here. So what is the total resistance between base B1 and B2? RB2 plus RB1. They are in series. Just like this. So that is called interbase resistance or BB. So RBB is equal to RB1 plus RB2. Now voltage drop across RB1 is VRB1. So by using voltage divider rule, VRB1 is equal to VBB into RB1 by RB1 plus RB2. This is also called neta VBB when IE is equal to 0. So what is neta here? RB1 by RB1 plus RB2. So here neta is called intrinsic standoff ratio. Neta is equal to RB1 by RB1 plus RB2, which is also equal to RB1 by RB2. Now the voltage or potential at point A is VA is equal to meter into VBB. Now see the operation here. I'm explaining this operation with respect to figure D. All of you observe figure D, ma? So first case, when VE is less than VA, what happens? Tell me. When VE is less than VA means dear students, please respond, ma. P side is connected to negative, yes, and N side is connected to positive. What happens? What is the status of the diode?
Reverse bias, sir.
Yes. Now here PN junction is reverse bias. PN junction is reverse bias. Now IE is negative. That is reverse saturation current flows. IE is negative, and this negative current is called IE naught. So it is in the order of 10 microamperes. Now we can say that UJT is in off position. UJC is said to be off. Similarly, when VE is equal to VA, means both the voltages are same. This implies IE will not flow. And the device UJT is ready to on. And UJT is ready to get on. Third case. Now when VE is equal to VA plus V gamma, where gamma is the cut-in voltage. VE is equal to VA plus V gamma. Means P type is more better than or more voltage than the N type, N side. Or we can say that VE is equal to VP, where VP is equal to, this is equal to VP, VA plus V gamma. Just V gamma, we are applying just more than V gamma. That is very small current flows in the device. And the curve reaches maximum voltage or peak point. I will dot the curve later. That is y-axis, peak point Vp. So when V is equal to Vp, when V is equal to Vp, a small current flows and the region to the left of the peak point, to the left of the peak point is called cutoff region. Now fourth case. Now when V is greater than VA plus V gamma, that is, it is greater than V gamma, cut-in voltage. Or we can say that V is greater than Vp, peak point, peak voltage. Here V gamma is cut-in voltage and it is equal to 0.2 volts for germanium and 0.6 volts for silicon. Now can tell me, now what is status of the diode? Here PN junction is forward bias. Now UJT is on. PN junction transistor is on. Current IE flows and increases. Increases gradually, just like our PN junction forward bias characteristics, V characteristics in forward bias. So this increases charge density. This increases charge density. This implies RB1 reduces. When RB1 reduces, VE. What is VE? VE is equal to voltage drop across RB1 plus the junction voltage there. See observe that figure D. This implies VE decreases. This region is called negative resistance region. And the last case, if B2 is open circuited. So that IB2 is equal to 0. Then VA characteristics are same as PN junction. Yes, have you noted this, ma? Yes, students. Yes.
Yes, sir.
Now see the
Sir.
graph, ma. VA characteristics. So depending on these 5 points, you have to draw the VA characteristics. So this is emitter voltage. In volts. Now this is emitter current. IE in milliamperes. This is called IB, valley voltage, and it is called VP, peak point. And this is called cutoff region, IP, IEB. This is IE naught. For the first case, IE naught. This is peak or the peak voltage or peak point VP, the current is IP. This is called valley point. And this negative resistance region. And this one is called saturation region. So when the emitter voltage is greater than VP, then the diode conducts. When the diode conducts, then due to IE increases. When IE increases, the charge density increases, due to which RB1 reduces. When RB1 reduces, VE reduces. Here, VE reducing here. This one. VE reduces. This is called negative resistance region up to this. Negative resistance region. So here where the resistance changes from negative resistance to positive resistance, that is called valley point, that is called saturation region. When it becomes saturation region, when B2 is open circuited. When B2 is open circuited, then IB2 is equal 0. This is called static emitter characteristic. Or UJT. So what is the cutoff region? When VE is less than VA, that is called cutoff region. There is no current actually. It is reverse bias. When it is reverse bias, a small current flows, that is negative current flows, that is called reverse saturation current, IA naught. That is called cutoff region. So this is cutoff region. Now, when VE is equal to just VP, that is VA plus V gamma, now it is ready to conduct and a small current flows. Now, when V is greater than VP, there is peak point voltage, then the diode is forward bias. When the diode is forward bias, IE flows. When IE flows, the charge density increases, due to which RB1 reduces. When RB1 reduces, the voltage VE reduces. Why VE reduces? VE is equal to the junction voltage plus the voltage drop across RB1. So when RB1 reduces, automatically VE also reduces. That's why here VE is reducing, decreasing here. This is called a negative resistance region. Now when B2 is base B2 is open, that is IB2 is equal to 0. Now it becomes the positive resistance region, that is also called saturation region. The point at which B2 is open is called valley point, or the voltage. Here the voltage is, this is VP, VE. Here This is VB, valley voltage. Valley voltage. And this is valley current, IB. And the current at peak voltage, VP, is called IP. Yes, have you taken this one, ma? Characteristics. Dear students, say yes or no. Lakshmi Sruja. Why you are not responding? Boys. No UJT applications. So what is the first application? To trigger SCR, we are using UJT. We will study what is SCR in the next class. Next. In sawtooth generators, sawtooth waveform generators, and third one, in phase control and timing circuits. Next one, as non-sinusoidal oscillator. These are the main applications of UJT. Yes, dear students, have you taken these points, ma? UJT applications.
Yes, sir.
Okay. Have you drawn this characteristics? Static characteristics. What is negative resistance region? Positive resistance region, that is also called saturation region. What is cutoff region? Have you noted this one?
Yes, sir.
Okay, we'll stop here. Thank you.